Okay, so I'm just going to go over exam practice 10.2 and looking at question 6 and just show you how I sort of went about it in solving that one. So pretty much for me, I just went through and actually drew up the graphs. I found that that was the best way. So I'm just going to move this over here so that I've got a bit more room. So all I did was I took this matrix M and I just drew it up. Then I know I've got 4 vertices. And I just labelled them A, B, C, D. You can call them whatever you want. All you have to do is make sure that the information matches from the adjacency matrix into your graph. So it's telling me that from A to A there's no edges. A to B I've got 2. So A to B I'm going to need to draw 2 edges. My A to C I've got 1, so I just draw 1 edge in there. And A to D I've got no edges. So then I move on to my point, my vertex B. So I know that from B to A I've got 2, which I've already got drawn in. From B to B I've got none, so there's no loop off of B. B to C I've got 2 edges, like so, and B to D I've got none. So then I'm going to go to C, and I know that I've got C to A 1, C to B 2, C to C none, and C to D none. And then coming down to my D, I've got 2, so I know that I've got a loop coming off of there, like that, or so that's how I drew it up. But I know that because there's no connection between D to any of the other vertices, that one's not going to be a connected matrix, which the question is asking for. So it's looking for a connected graph. Okay, so I'm going to move on to the next one. So for N, I'm going to look at it and go again A, B, C, D. So A, B, C, D. A to A none, A to B none, A to C I've got 2. A to D none. Then I've got B to A none, B to B none. Then I've got B to C. I've got 1 edge, like so. And B to D, I've got 2. So already there, without completing the rest of the matrix, I can see that it's a connected matrix. I can get from every point to all the rest. So I would say N. You can go further and see if the rest are connected, but that's how I would work through that question, just drawing it up and looking at the visuals. The other suggestion is to have a look at worked example 6 and how they've gone through and answered that one. So they've actually looked at, so if this is the leading diagonal, what they've done is they've used the numbers down below here to give the number of edges. So you can see that there's 2 plus 2 plus 1 is 5, so 1, 2, 3, 4, 5. So if we know that if E equals 5, and we know that we've got 4 vertices because we've got 1, 2, 3, 4, we could go through and use Euler's formula to see if we get an answer. And if it is true, then that would mean that it is a connected graph, because of course it needs to be connected and planar to fulfill that equation. So that's just a different way to do it. So whichever one works for you. I'm a visual person, so I like to use the diagrams and draw it out, but that's just another way that that you could work it through.